Okay, so here we want to find the area inside r equals 4 plus 4 sine theta. So first, let's see what kind of graph we have here for 4 plus 4 sine theta. I go back here, I already have my parameter a there, which I'll use in a moment. Let's put in our equation. R equals 4 plus 4 sine of theta. Okay, so this is telling me my constraints need to run all the way to 2 pi. So I'm going to go ahead and put, well, let's zoom out and look at the graph first. Let's see what we have. And so we have that heart-shaped cardioid that we're dealing with, or again, as I like to think of it, as the plumber's crack. It always looks like to me anyway. All right, so let's see how this graph actually gets generated here by putting in my parameter a and then using my slider here. So my graph starts off positive for a while, continues positive, and still positive, right? And in fact, this thing would be, hang on, my mind's just stopped working for a minute. This thing's always positive. I'm sorry. I don't know why my mind was even thinking something else there. But anyway, so all the way through the second quadrant, and finally we hit 0 there, and we hit 0 there. So since I don't have a nice smooth piece where I can break it, like if I could look at it from here to here, but to do that I'd have to go from negative pi over 2 to pi over 2, and that's kind of messy. I like having 0 as one of my endpoints. So since this is just coming all the way around, and there's no nice piece I can just slice off one piece and say, oh, let's do that piece, and then double it like I was able to do before. Here I'll just stick with the fact that I got to go from 0 on the angle all the way around to 2 pi. Okay, so that's the first quick little thing to realize what we're dealing with and what kind of area or constraints we're going to need. In this case, we're ranging from 0 to 2 pi. Okay, so we set up our integral now. Integral, again, is the integral from a to b. So there's no doubling or anything this time, so it's just 0 to 2 pi of 1/2 of my function squared. 4 plus 4 sine theta squared d theta. And now we just got to work this integral out. Towards that end, we have a sum, a binomial squared. Remember, when you square that, that'll be the first thing squared plus twice their product plus b squared. So just making life a little easier. So all that stuff's going to get squared, and it's going to be multiplied by 1/2. So let me do both of those things at once here together. So 4 squared is going to be 16. Half of that will be 8. In the middle, I'm going to have 2 times a times b. So 2 times 4 times 4. So 32 sine theta times 1/2 would be 16 sine theta. And then I'm going to have that squared, 16 sine squared times 1/2 will be 8 sine squared theta d theta. And then remember here that this is going to be 8 times 1 minus cosine 2 theta, all that over 2, right, for that piece, which would make that plus 4 minus 4 cosine 2 theta. Okay. So putting everything together now, we'll have the integral from 0 to 2 pi of 8 plus 4 would be 12 plus 16 sine theta. And then if finishing it off, minus 4 cosine 2 theta. Just to save myself a little bit of writing here, though, I'm going to make an adjustment to that. The 2 theta inside is going to require a 2 for the substitution, so I have 2 d theta. So I'm going to take that 4 and actually break that into minus 2, and then I'll have my cosine of 2 theta and another 2 outside, which would eventually get absorbed with the d theta. And I'm just doing that so that I can save myself a little bit of writing, not writing out the full substitution stuff or breaking up my integral. I know that 2 is going to disappear. Okay? And then everything else I can just carry the integration through. So we do that. Integral of 12 is just going to be 12 theta plus 16. Sine when integrated is negative, so that's actually going to be minus 16 cosine theta minus 2. Integral cosine of sine, and we've already accounted for the 2 to go with the d theta, so that's just going to be minus 2 sine 2 theta, and then we're going to evaluate this between 0 and 2 pi. Okay, so first we plug in 2 pi, it's going to be 12 times 2 pi will be 24 pi. Plug 2 pi in for cosine, that's going to be minus 16. And plug 2 pi into sine, twice 2 pi is 4 pi, which is still sine of that, still 0. We get all that stuff. And then minus, and then on the other side, plug in 0 for theta. 12 times 0 would be 0. Minus 16, cosine of 0 is 1. And sine of 0 is still 0. So what's actually going to happen is these 16 here and the 16 here are just going to cancel out. So the whole thing just becomes 24 pi. Just end up with an area of 24 pi. Okay, so here we've been able to work out that area. Of course, that's a much bigger shape. We know that. So that's why it has a much bigger amount of area, of course, than some of our other examples.